Hey, what's up everybody? Who wants to do more Lewis structure practice? I know I sure do. Let's lock and load. This example is going to take a look at water, H2O. Step 1. Determine the total number of valence electrons in the molecule contributed from each element. Hydrogen, it's got 1 valence electron. Oxygen, 6 valence electrons. Boom. Keep in mind, we've got 2 atoms of hydrogen, each contributing 1 valence electron, for a total of 2 valence electrons contributed for this molecule. Oxygen, on the other hand, we've only got 1 atom of oxygen, but each atom has 6 valence electrons, so 6 contributed from our oxygen. Total, we add them together, 8 total valence electrons contributed from all of my atoms in this molecule. Step 2. Determine the total number of valence electron pairs available. So we take our total number of valence electrons determined from step 1, divide by 2 to get our total number of valence electron pairs. Step 3. Build our skeletal structure by choosing a central atom. Again, you're going to go to your periodic table, remember your trend in electronegativity, but in this example, again, I've got hydrogen as one of my elements, and that one is never going central. So oxygen's going to go in the middle. I'm going to surround it by my other atoms, in this case, just 2 hydrogens. Step 4, place a pair of electrons between that central atom and each of the terminal atoms. Again, I'm going to color code here to help you recognize that one of the electrons in that pair is coming from the central atom and the other electron is coming from that terminal hydrogen. This time, I only need to use 2 pairs to connect my central atom to the terminal atoms. I have 2 pairs left over. Oh my goodness, what am I going to do? Well, turns out if you have pairs left over, the first thing you do is you try to give them to those terminal atoms. In this case, my terminal atoms are hydrogen, and they're not going to accept any additional electrons. So if you can't give them to the terminal atoms, you give them to the central atom. Oxygen is more than happy to accept them. I subtract those 2 that I used to give oxygen its octet. I have 0 pairs left over. I want to stop and check and make sure that every atom that needs an octet gets one. In this case, oxygen is the only one that needs an octet. My hydrogens are completely content having just 2 electrons. That completes their valence level. Again, don't forget you can represent the Lewis structure with those bonded pairs of electrons represented by dashes. Woo! Done.